Hi, this is Kevin. Welcome to part one of my tutorial for the coding assignment associated with the Severance chapter 11 of the Severance Python book. In chapter 11, we're working with regular expressions. And here we're just going to go through an interesting file and count the occurrences of a word that has a pretty high frequency in the text. So, what text are we going to use? Well, let me open up this journey.txt. And this is a file that I downloaded from Project Gutenberg, and it's an open source text of the novel A Journey to the Center of the Earth by Jules Verne. And I had read this novel, or some kind of a child's adaptation of it, more likely, as a young man, and I really liked this book. And I reread it within the last year, and I really liked it again. So I thought, what's a good old book that we could get an open source copy of that I knew a word we could look for? And it's this. Now, this is a story about a young man and his uncle who go on this great adventure to the center of the earth. And the young man is the narrator, and he uses the word uncle a lot. In fact, here we're just going to look. My worthy uncle. Okay. And it says, but my uncle. Okay. And it goes on. Why my uncle? Uncles all over it. Okay. So I thought, well, this would be a great one to write a program to do some searching of the lines of the text and do some counting of how many times we find uncle in what kind of position in the line of text. So that's what we're doing. So I wrote a tutorial example called My Uncle, and I'm going to open that up. And let's see. It starts out with the name of the file, count lines containing a target string. That's the word uncle in the input file. Okay, that's good. Um, so let's look at it. Well, we begin with an import of RE, that's the module for regular expressions. And then all of our code is in the main. And it fits into the main. It's a little bit long for a main, but not too bad. And then at the very end, of course, we have the call to main. All right, that makes sense. And let's see, we've got kind of three sections. We have kind of sort of housekeeping in the beginning. And then we've got the processing line by line. And then in the end, we're printing the outputs of the program. So what are the outputs of the program? Well, there are a bunch of counts. And what kind of pattern did we base this on? Well, we based this on the counter pattern, which is kind of the trivial case of the accumulator pattern. Every time you find an instance you're interested in, you bump the counter up by one. So what are we counting? Well, let's see. Let's just look at the counters. So here's a count. It's called line count contain. These are the number of lines that contain the word uncle at all. Line count begin. These are the number of lines that begin with the word uncle. That's our target string. Line count end. These are the number of lines that end with the word uncle. line count begin or end. This is a count of the lines that begin with the word uncle or end with the word uncle. And line count begin and end. These are number of lines that begin with and end with the word uncle. I don't know that we have any of those. I don't think we do, but it's possible. Okay, so what are we going to do? Well, we have a processing loop, and we're using the for in approach to reading from the input file, which we have opened with the variable name in file. And so we go through this loop, and then the first thing that we do is we want to make sure that we find that we don't take the capitalization of uncle into account. So if we have uncle with an uppercase U or uncle with a lowercase u, we want to treat them both the same. And as is pretty typical in these text analysis application, we do that by taking the whole line and shifting it to lower by calling the lower method on the string. Okay, and then we have a bunch of tests. Okay, so we use the search method from the regular expression object, and we're saying if we, so the first thing is we're doing a search. The regular expression is just a string for uncle. Okay, it doesn't have any meta characters modifying it. So this is going to count. This is going to come back as true if the word uncle occurs anywhere in the line. So we're going to bump up the line count contained by 1. Next, we're using as a regular expression, we are prefixing the character string uncle with a circumflex that says it has to match from the beginning of the string. So uncle has to be the first word. The next one is we follow the character string uncle by a $sign, and we say it has to be at the absolute end of the line. Can't even have a space after it. Okay. Now, the next one is the beginning or the end. So we have essentially two regular expressions separated by what I call the OR bar. So either it matches the string that begins with uncle, or it matches the string with the end of uncle. Either one. And the very last one is we're looking for a line that begins with uncle and ends with uncle. So we take, we have the circumflex uncle, and we have the uncle $sign, and we use those before. But in between, we say that we use the period, the dot, and then the asterisk. And so we're saying 0 or more other characters, any other kind of character in between those two, as long as we begin with uncle and end with uncle. And in fact, it could just say uncle. It could just say uncle, right? One time, in case it would begin with uncle and end with uncle. All right, and because these characters in the middle can be 0. At a minimum, we're going to need an uncle. Okay, so we bump up the count each time. All right. And then the polite thing to do with your file is to close it. So we've done all the reading. We close it. And we've done all the counting that we have. And so we're going to print out each one. So we have the contain count. And then we say lines in the file contain the target string. Okay. The count begin, contain the target string at the beginning, and contain the target string at the end. Begin or end, contain target string at the beginning or at the end. Begin and end, contain target string at the beginning and at the end. Okay. Now, I've got to I've got to admit that if you are developing this code from scratch, right, and you want to have some test data, you probably are not going to test it first with this journey.txt. Why? Well, because it's hard to count what the values are. Now, I've already done some testing on this with a much fewer lines of text. And I've already proven myself so that it works. So I'm just going to demonstrate it with the big file. Okay, so let's do that. So let's do myuncle.py. Let's give this a run. Run myuncle. Okay. And the file is called journey.txt. And what did we get? Let's look. Well, we have 503 lines contain the target string. So uncle occurs on 503 lines. 27 lines in the file contain the target string at the beginning. So the word uncle is at the very beginning. 10 lines in the file contain the target string at the end. 37 lines in the file contain the target string at the beginning or the end. 0 lines in the file contain the target string at the beginning and at the end. Okay, so why do I know that this is the right answer? Well, because I tested it on a smaller file that I concocted. All right. Should you decide to put this to make this work? First of all, you'll find journey.txt in your starter files. Okay, and then you'll be able to look at the answers that we have right here. So 503, 27, 10, 37, 0. That's what you're looking for when you get the code right and you process journey.txt. Okay, so I'm going to turn you loose on your first exercise, which is very similar to this, but we're looking in a different file for a different word. But other than that, we're trying to collect pretty much the same counts. Okay, so having access to this code is definitely going to be helpful, which is why I showed it to you. So good luck on that, and I'll see you next time. Bye-bye.